Welcome all. In this lecture, we are discussing analysis of simple AC circuits. So firstly, we can consider AC through pure resistance. Consider a pure resistor across which we are applying an AC voltage. So this is a resistance with R. I is the current flowing through it when voltage V is applied across it. V is a pure AC voltage V equal to Vm sin omega t, a sine wave with maximum value Vm. So for a resistive circuit we have I equal to V by R. So here V is Vm sin omega t. So it becomes Vm sin omega t by R, and it becomes I equal to Vm by R sin omega t. Means if we are applying a voltage V equal to Vm sin omega t, a sine wave with maximum value Vm, the current will be also a sine wave with maximum value Vm by R. So for a resistance, if V is the applied voltage V equal to Vm sin omega t, the current will be Vm by R sin omega t. So we can plot the waveforms of voltage and current as like this. Both will be starting from 0 and be sine wave. Voltage will be having a maximum value Vm and current will be maximum value Vm by R. Im equal to Vm by R, where the maximum value of current will be depending upon the value of resistance R. So from this we can draw the phasor as both are starting from 0. So both vectors phases will be 0 phase angle. So we can draw like this. Vector V and vector I will be having 0 phase with the reference line, and the vector V can be represented as a magnitude, the RMS value of voltage, and angle as 0. So V angle 0, where V is the RMS value of the voltage, which is Vm by root 2. V is Vm by root 2, and current I is magnitude and angle is 0. So current I is, the magnitude is V by R. So there is the RMS value of current. So it is this peak by root 2. So it is V by R. So this is for AC through a pure resistive circuit. So should be noted that here the voltage and current are in phase. So it is called current is in phase with voltage in case of a pure resistive circuit. So next we can analyze AC through pure inductance. So consider a pure inductor across which we are applying an AC voltage. So L is the inductance of the inductor, and we are applying V equal to Vm sin omega t, a sine wave with the maximum value Vm across the inductor. So a current I will be flowing through it. So for an inductor we have the equation V equal to L di by dt. Again V is here Vm sin omega t. So Vm sin omega t equal to L di by dt. So we can find di as di is equal to Vm sin omega t by L into dt. So we can find I by integrating this equation. So I equal to integral Vm sin omega t by L dt. Again Vm and L are constants, so we can take it outside of the integral. So I equal to Vm by L integral sin omega t dt. Again we have to integrate sin omega t with respect to dt with respect to t. So omega is constant. So sin omega t, integral sin omega t is minus cos omega t by omega. So by omega is here. So Vm by omega L integral sin omega t minus cos omega t. So again cos minus cos we can write in terms of sin as sin omega t minus pi by 2. Okay, so Vm by omega L is minus cos is, we have sin omega t minus 90 degrees minus cos. Okay, so we can write like this, sin omega t minus 90 degree or pi by 2 radian. Again we can term this omega L as XL. So I equal to Vm by XL sin omega t minus pi by 2 is the current, where XL is the XL equal to omega L. We are substituting omega L as and terming as XL, which is called inductive reactance, which is equal to omega is 2 pi f. So we can write as 2 pi f L. F is the frequency. So this XL is depending upon the frequency and the value of inductor L. So inductive reactance can be defined as the ratio of maximum voltage to maximum current of an inductor, and its own unit is ohm because it is a ratio of voltage and current. Okay, so means this is actually Vm by, this is actually Im. So XL is Vm by Im. Okay. So that is for pure inductance. If V equal to Vm sin omega t is the applied voltage, the current will be equal to Vm by XL sin omega t minus pi by 2, or XL is omega L equal to 2 pi FL. So from this we can plot the waveforms of voltage and current. Voltage is starting from 0 sin omega t with maximum value Vm. I is lagging pi by 2. Maximum value is Vm by XL. So it will be like this. Voltage is like this, starting from 0 with maximum value Vm. I is starting from pi by 2 with maximum value Im, is depending upon XL, Vm by XL. Okay. And from this we can draw the phasor as like this. V is starting from 0. So now phase angle is 0. Current is starting pi by 2 in delay of pi by 2. So I is lagging by 90 degree or pi by 2 radian. Okay, 90 degree. So V and I like this. Again, vector V can be written by the length is V, the RMS value, and angle is 0. So V angle 0. V is the RMS value of the voltage, Vm by root 2. And I is V by XL. Okay, so V by XL and angle is minus 90. Okay, it is lagging. So minus 90. V by XL minus 90. So we can say here, if you are looking, the current is lagging the voltage by 90 degree. So current lags voltage by 90 degree in pure inductive circuit. So next we can analyze pure capacitive circuit. So consider a pure capacitor across which we are applying a AC voltage. So V is the applied voltage, V equal to Vm sin omega t, and we are applying across the capacitor with the capacitance C, and I is the current flowing through it. So for a capacitor we have the equation charge Q equal to CV. So if you are differentiating, we will get dq by dt is equal to C dV by dt. C is constant. So again dq by dt is the current I, so I equal to C dV by dt. So here V is Vm sin omega t. So we can substitute for V. So we will get C I equal to C d by dt of V is Vm sin omega t. So Vm is constant and differential of sin omega t is sin omega t cos omega t into omega. So C Vm cos omega t into omega. So it become omega C Vm cos omega t. So again we can write cos omega t in terms as sin omega t plus pi by 2. Sin omega t plus 90 degrees cos omega t plus cos omega t. So we can write cos omega t as sin omega t plus pi by 2. So again this term is omega C Vm. So we can write this as in case of resistance and inductor as Vm by some value. So is Vm by 1 by omega C. This is omega C into Vm. So Vm by 1 by omega C. So again this term is like in case of resistance it was Vm by R. So in analogous to that we can write as I is equal to Vm by Xc sin omega t plus pi by 2, where Xc is 1 by omega C. We are substituting for 1 by omega C as Xc, another term. It is called capacitive reactance. Again omega is 2 pi f, so equal to 1 by 2 pi fc. So Xc is depending upon value of f and value of capacitance. And again if you are looking here, this is the maximum value of current Im. So X is actually the ratio of Vm and Im. So capacitive reactance is the ratio of maximum voltage to maximum current of a capacitor. So unit is again ratio of voltage to current, so it is ohm. Unit is ohm. So for a capacitance V equal to Vm sin omega t, then I will be Vm by Xc sin omega t plus pi by 2, where Xc is 1 by omega C omega c or 1 by 2 pi fc. So from this equation we can plot the waveform as we will be starting from 0. I will be starting early by 90 degree. So I is starting from here. Okay, so it is like this. I is starting from here early, 90 degree lead. Okay, so V is like this and I is like this. V is having maximum value Vm, I is having the maximum value Vm by xc. So we can draw the phasor as V is having no phase angle. So V is like this and current is plus pi by 2. So it is leading by 90 degree. So again we can write the equation as V vector V is equal to V angle 0, where V is the RMS value of the voltage Vm by root 2 and I is maximum value of magnitude of I is maximum value of the current. So it is Vm by root 2 by xc. So it is V by xc. V by xc angle 90 degree. It is leading. So it is plus 90 degree. So here the current is leading voltage by 90 degree. So in pure capacitive circuit, current leads voltage by 90 degree. So if you are comparing pure resistive, inductive and capacitive circuits, for resistance, I is equal to Vm by R sin omega t. Inductor, I equal to Vm by XL sin omega t minus pi by 2, here plus pi by 2 in case of capacitive circuit. Again here R is the resistance, here XL is the inductive reactance, omega L 2 pi FL, here XC for case of capacitor, X is the capacitive reactance, which is 1 by omega C by 1 by 2 pi Fc. So if you are comparing the phasor, in case of pure resistive, voltage and current is in phase. Here voltage is V angle 0 and current is V by R angle 0. Here voltage and current are like this. I is lagging. Okay, here current is leading V by xc plus 90 degree. So in resistance, current is in phase with voltage. Inductive circuit, current lags voltage by 90 degree, minus 90. So here also. And in case of capacitance, current leads voltage by 90 degree, plus 90. Here plus. Okay. So with this we can wind up this session. Thank you.